Here is another AP Pre-Calc lesson. Today we're looking at 1.5-1.6, writing and graphing equations of polynomials. So this section is a section that really sees how much we know and how much we remember from what we learned in these prior sections. Okay? In order to go through this stuff, what we want to do is either create an equation or use an equation to graph it. We're going to start with creating an equation. So we want to create some function, maybe f of x. Well, in order to do that, we should first understand that a polynomial in its factored form takes this form. F of x equals a times x plus something times x plus some other thing. And then you can keep those parentheses going depending on the amount of factors you actually have. Okay, well, realize we've talked about linear factors before. Linear factors help you to find the roots. Remember, roots are the same thing as x-intercepts. Okay, well, let's use this information that we have so far. Let's start to create an equation. One thing I know is, okay, we have two different x-intercepts. We see both of them there. One that occurs at x equals -1 and one that occurs at x equals +5. Well, remember, to create linear factors, you move the value to the other side so that your equation is equal to 0. So I could add the 1 on both sides, get x plus 1 equals 0. I could move the 5 to the other side, get x minus 5 equals 0. I know those are the two factors that I need for this polynomial. But when we were doing factors, we didn't just create the factors. We also had to look at this thing called multiplicity. And remember, multiplicity was the exponent on the parentheses. Okay, but now we have to remember what the multiplicity did. Multiplicity, when I think back, multiplicity told us what happens at the x-intercept. It tells me whether it goes through the x-intercept or whether it bounces off the x-intercept. Okay, well, now I need to remember which was which. We always talked about multiplicity as even versus odd. And what you would look back and find, or what you might remember, is that odd multiplicity goes through. So at x plus 1, we know the multiplicity is odd. Let's go ahead and say the exponent's a 1. At the x minus 5, it bounces off, so the multiplicity has to be even. So let's say maybe it's 2. Okay, we can just use the smaller numbers for now. We don't necessarily need to create big numbers. Okay, well, all we're really able to find so far is just that information. We don't know a either. Well, one thing that happens is we're always able to find a. You can find that because the other information that I know is this y-intercept. In other words, I know that we have the coordinate 0, 150 on this line. Well, okay, that tells me the x is 0. That tells me f of x is 150. So now I can start to replace those things. Instead of f of x, I use 150. Instead of any of the x's, I replace them with 0. Well, if I go through this process of solving or simplifying that for a, I then find the value of a. Well, let's see what that would end up giving us. If I square -5, remember, a negative squared always comes out as a positive. Negative times a negative is a positive there. That 1 I really don't need because it's just multiplying with 1, and that's all equal to 150. Well, move the 25 over. You could divide 25 on both sides, and you'd end up finding a value of 6. So, okay, well, that gives me the actual equation then. We just created the actual polynomial that is shown. F of x equals the a value we found of 6 times x plus 1 times x minus 5 quantity squared. That is the equation we were shown. Well, one thing that I want you to pay attention to when you go through this process. Notice our a value is positive. Notice our degree, x squared is x cubed. So our leading term would be 6x to the third. One thing we talked about is end behavior. This is a positive odd degree. That tells me the right side would go up. Odd means that they go opposite directions, so the left side goes down. Notice that is true for what the graph shows us as well. We just verified that the end behavior of the graph is the same as what we came up with. That does give me good insight to whether we did this correct or not. That is how you could create the equation given a graph of a polynomial. Now let's go the other direction though. Let's say that we're given an equation and now we need to do the opposite. We need to create the graph. Well, again, one thing we need is the x-intercepts, so we could find that. Well, we're given the factors. For example, I know one of my factors is 2x plus 6. And I know that that's equal to 0 right now because it's a factor. But if I need the x-intercept, I can solve for x. I can move the 6 over. I can move the 2 over. And I would end up finding x is equal to -3 is one of my x-intercepts. You could do that for each of these different factors then. X minus 3 equals 0. There's an x-intercept at +3. X minus 5 equals 0. There's an x-intercept at +5. Notice there's one factor that is not in parentheses. That factor is x squared. If you ever have x squared or x in front of the parentheses, where it's not being added or subtracted with anything, well, whenever you move that value then, or you isolate x, if there's nothing adding or subtracting with it, you're always going to get 0. Because if you have 0 divided by something or 0 times something, or in this case, the square root of 0, you're still just going to get 0. So if there's ever just an x in the front, you should be able to kind of immediately tell the x-intercept is 0. Well, notice we also need to know the multiplicity. I know the multiplicity at 0 is 2. That means it's even, it's going to bounce. I know the multiplicity at -3 is also 2, so it's going to bounce. Versus the multiplicity at both of these will go through. Okay, well, that tells us what happens, but is it going to be on the bottom bouncing and then going through? Or is it going to be the complete opposite of that, where it might be on top instead? Well, the only way that I can figure that part out is by thinking about the end behavior. In this case, if I look at the multiplicity, we said our multiplicity is 2, 2, 1, and 1. I know that my degree then must be 6, found by adding all of those components up. I also know by looking at what's out in front that this is a positive function, a positive polynomial. So, okay, now I know that it's positive and even. That tells me both sides must go up. All right, well, from there then, if both sides are going up and it's even, I can look at both the sides where my x-intercepts are the furthest out. From there, no matter what happens, my graph has to go up forever after those points. Well, now I just need to fill in whether it bounces or goes through. I know that the multiplicity of 2 at x equals 0 means it bounces, but okay, I'm not there yet. I need to look at this -3 spot. Well, at -3, it bounces, okay? So my graph turns back around. The next one I'm getting to is 0. So, okay, look at 0. Oops. Look at 0, and again, the multiplicity is even. Multiplicity is even, so again, it must bounce. But then at 3, it's odd, so it's going to go through that. And then at 5, it's odd, so it's going to go through that. And that's not the smoothest drawing, but you guys can see the shape that is actually happening now. The first thing you need to graph is the end behavior, from the outside x-intercepts, and then you can graph the inside based off of whether the multiplicity is even or odd, telling you whether it bounces or goes through. On other problems, you might have to find the y-intercept as well. The y-intercept can be found pretty simply. In this case, I didn't necessarily need to find the y-intercept. The reason I didn't need to find it is because we knew it was at the origin. But if you do need to find it, that can be done pretty easily because the y-intercept is always when x equals 0. So if you take your function and just plug in 0 for each of those spots, then you can end up finding the actual value. In this case, though, what you'll first notice is our first parenthesis or our first value is 0. That multiplies with everything, and so we still end up finding the y-intercept of 0. That is 1.5, 1.6, writing and graphing equations of polynomials.